So today we're going to talk about Android for the enterprise. So that means many things to many people. I'm going to have my own sort of way of looking at what enterprise is and what the concerns are. So that's what we're going to talk about. Before we get started, just want to tell you a little bit about myself. So my name is Marko. My background is in Java. So I'm a Java developer for a very long time, before I was Java, since it was a little project at Sun called Oak. Once Android came out, I got really interested in that and started poking around, playing with it. And out of that, I developed a Android Bootcamp, which is a 5-day course, taking people who know Java all the way to being able to develop just about any application in Android. And since then, I basically bottled that course into a book called Learning Android that was published by O'Reilly last year, and since has been translated into Chinese and German and Croatian, and it's one of the top 10 best-selling Android books. I also run San Francisco Android Users Group and frequently speak at conferences and such. So that's a little bit about myself and my background. These days I focus mostly on the internals of Android, so you can ask questions regarding the internals, the security, things of that nature, but I also understand the app development reasonably well, so I can help you with those answers as well. So what we're going to talk about is a couple of things. We're going to talk about the vision for Android. So basically, what is that got, how the motivation for the Android project came about. So we're going to discuss that and kind of look at that context, because I think it matters a lot in understanding why Android is put the way it is today. Then we're going to look at the stack. So basically starting from the Linux kernel all the way up to the apps. And by doing so, we're going to explore various enterprise issues at each layer of the stack. So that's essentially the goal. I'm going to give you a little Hello World example just to kind of show you what the tooling looks like. You know, how is it hard or easy to build Android apps? So just a really quick overview of what that looks like. We're going to talk about security, enterprise features, and then some final conclusions in terms of what we're exploring. So that's roughly the overview. Starting with the vision. So back in 2005, Google went out and bought this little company in Palo Alto called Android Inc. And at that time, it was sort of off acquisition. Google wasn't really going around buying companies back then, right? It wasn't like last year where they bought a company every single week. 2005, they weren't really in acquisitions all that much. So this was sort of off for the marketplace. And a lot of people suspected that Google was going to enter the mobile business. In other words, people thought that Google was going to create a G phone. Right? That was sort of the word on the street. At that time, Eric Schmidt came out and he basically said, look, our goal is not to create yet another gizmo. That's not our business. Our goal is to create a mobile platform that's going to run on many, many different devices. So understanding this vision is going to help us really understand a lot of different technical decisions that were made in Android subsequently, right? So it's a mobile platform, and it's supposed to run on many, many different devices, right? So that's kind of important design considerations in Android. And it has its implications on the enterprise. So the design philosophy was basically just about that, to basically create a mobile platform for many, many different devices. And while doing that, they had to keep in mind the entire ecosystem. And by ecosystem, we mean the device manufacturers, so people who are actually making the gizmos, the devices, network carriers, because they're going to be selling them, app developers, because they're going to be providing the actual value at the end of the day, and the end users who are going to be using these devices and hopefully loving them, right? So keeping all these constituencies in mind is something that was very important to when designing the Android platform. So I'm going to start by talking a little bit about open source, or the open nature of Android, because I believe this is one of the key differentiators of Android platform versus pretty much everything else that we have out there in the marketplace, right? As opposed to comparing Android to other platforms on feature-by-feature basis, I'm going to look at more the fundamental differences, right? So one of the fundamental differences is that Android is open, and that has a lot of implications to the enterprise customers. But being that it's an open source project, it doesn't mean that you somehow have a license to do whatever you want. It doesn't mean that at all. Open source basically means that you can see the source, but the license can be any number of different licenses that are out there. And there are probably hundreds of different open source licenses. Now, when it comes to open source licenses, not all the licenses are equally important. There may be a dozen or so that are kind of prevailing out there in the wild. And out of all those licenses, I kind of split them into two buckets to help you understand the implications of the licensing on a lot of technical decisions made in Android. So basically, my bucket split is based on the question, does the derivative work fall under the same license? In other words, you as an enterprise, you take certain open source code, and of course you can see the source code and you can modify it, but once you modify it, who does the derivative work belong to? Does it belong to you, or does it belong to the community from which you inherited the original piece of work from, right? And that's a really important question, because if you do not get to own the changes, then you're less likely to put your engineers at work to keep creating changes and creating IP that you cannot claim. So when it comes to the open source licenses, I'll just go straight down to the bottom. So the ones that you do not own the changes are LGPL, so lesser general public license, and GPL, general public license, licenses. So these are the licenses that are, in Android terms, unfriendly to businesses, right? Because they don't foster that goal of, or that mission of, running on many different devices. So Android tries to keep away from these licenses. Now, on the flip side, the ones that are friendly, that we get to keep the derivative work, are basically the Apache 2, MIT, and BSD licenses. So a lot of code that we try to inherit in Android is based on this. And this is going to matter later on. I'll explain why and how. So that's a little bit about the open source licenses. So basically the bucket where you get to keep the changes and the bucket where you don't get to keep the changes. That's essentially it. Now, let's explore the Android stack, sort of to take a look at the big picture of the entire system, how it's put together, and what some of the implications in terms of the enterprise concerns are. So, so this is basically the big picture outlining the entire Android stack. At the bottom, we have the Linux kernel, we have native libraries, native layer, we have the application framework, and finally, we have the apps at the top of the stack. Most of you have seen a picture like this before, right? One way or another. So what I'm going to do is I'm going to show you a slightly more detailed view of the very same picture, right? So in my little more detailed view of the world, we have, let me kind of position it like this. So we still have the Linux kernel. Now, the native layer, I split it into basically multiple components. So on one hand, we have hardware abstraction layer, which is basically Android's way of dealing with drivers. It's sort of unique to Android with respect to how it does that. Native libraries, so these are libraries that are C, C++ code, often borrowed from other open source projects. Native daemons, again, native code. And then a bunch of tools that we have, mostly Linux type of tools. So this is our native layer. Then we have the Dalvik virtual machine on top of that. And then we finally have the application framework layer. And within that, we have the Java libraries, which are the standard Java libraries, except for those 9 lines of code. I don't know if you've been following the Oracle versus Google lawsuit. So the judge did find 9 lines of code copied. And basically, it is an infringement, but it's only 9 lines of code out of like.
Software degree was able to find the 9 lines.
Well, the lawyers basically poked through that.
Oh, they pointed out to them.
Yeah, it was basically an honest mistake on Google part. They copied the range function, something that a high school kid can implement, basically. So, Google was found guilty, but the punitive damages are 0 or something like that. So it's not a big deal. This is an application framework, so brand new code represents all the functionality that Android exposes to the apps, right? Like, so if I want to find out what my location is, as an app developer, I just simply say, hey, what's my current location? And the app framework just magically tells you, hey, this is your longitude and latitude. But below the surface, there's a lot of magic going on, right? System services are also part of that app framework. And then finally, at the top of the stack, we have the apps, and they come in two flavors. They're the apps that are baked into the platform, so they're kind of etched in the device, and you cannot take them off the device. And then there are user-downloaded apps. Okay, so that's basically breaking the previous picture into a little more details. So now we're going to walk through various parts of this, and we're going to go bottom up, and we're going to talk about the concerns. So at the bottom of it all, Android is based on Linux. So Android runs on top of Linux kernel. So I often ask people, why did they pick Linux? Any ideas out of you guys? Why Linux? If you're building a platform like this.
Open source and free.
Open source and free, those are good reasons. Anything else? How about security? Linux is considered fairly secure, right? It's been in the harsh environments over the decades, and it's been patched pretty well. So it's secure, it's open source, and the price is right? It's free. But then, why not, for example, BSD, which is another open source, even more open, I would argue, because it's a BSD license, so it's friendlier, much friendlier in terms of what Android needed. It's even more secure. By according to some people. So why not BSD versus Linux?
More people do Linux.
Adoption, yeah, you guys are right. Because remember, the vision for Android was to run on many, many different devices. So they did actually consider BSD. But BSD doesn't have nearly as wide of the driver support, as device support as Linux does. So that's one of the reasons why they picked Linux. So basically, Linux provides that low-level security model, which I'll talk about later on, which is something that's very, very important to the enterprise customers, how the security is implemented on a platform, right? And in a nutshell, Android outsources a lot of its security down to the Linux kernel, and Linux kernel is something that's proven for a while to be fairly secure. We also use Linux for memory management, process management, the radio interface runs as a native daemon inside of Linux. Device drivers are part of the Linux kernel as well. So those are some considerations for Linux that are good. Keep in mind, sometimes people think, oh, this is yet another implementation of Linux, right? So Android is just like Fedora or Red Hat or Ubuntu, and it's not. It doesn't. Although it's based on the Linux kernel, it doesn't have a lot of things you would expect from standard Linux. For one, from enterprise point of view, there are no users, right? On standard Linux, I can go and add user Bob, right? I can add that user. In Android, we don't have physical users. There are logical users, but not physical users. So it's a totally different sort of approach to how the operating system is put together from kernel up. But the kernel itself is more or less the same. So I keep saying more or less the same. In the old days, a couple of years ago, the kernel the Linux kernel for Android diverged quite a bit from the main branch. So there was sort of almost like a political issue going on between the Linux maintainers and the Google kernel guys. And so they kind of went on their own separate branches, and it was very political and kind of heated debate over that for a while. But as of recently, it seems like that things are getting cozier. So a lot of Android changes to the kernel have been adopted by the Linux maintainers. I think we're only about 7,000 lines of code difference right now, so it's peanuts compared to what it used to be. So things are getting better in terms of that, which is good because it provides for longevity of the platform, given that Linux has a huge adoption behind it. So that was a little bit about the kernel space. Now we're exploring the native layer, and as I said earlier, that's basically this part of the stack. Couple of things that are kind of interesting here that I mentioned earlier. So how is hardware abstraction layer? It's needed because Linux has a lot of drivers, but it doesn't have a standardized driver support. So if I'm going to write a platform that's going to run on many different devices, if I'm going to write, if I'm expecting an application, Angry Birds or some enterprise app, to run on a Samsung, Motorola, HTC, and whatnot device, then I need a very clean access to the drivers, right? And each manufacturer may implement GPS driver differently, for example, right? So HAL is the abstraction layer that abstracts the driver that is sitting underneath in the kernel space. So that's something that's very useful that Android provides sort of as a way to put everyone on the same page. So that's a good thing. The native libraries we talked about are mostly copy-pasted from other projects, daemons, and tools that we have here. So what we're going to do next is we're going to look at Dalvik. Dalvik is, I would consider it a crown jewel of the entire platform. It's basically the engine that runs every single app on Android. So every single application on Android runs on a instance of Dalvik virtual machine. So Dalvik is essentially a replacement for Java virtual machine, right? And most of you guys are familiar with Java virtual machine, what it is and what it does. So a lot of people think that the reason why Google created Dalvik was to bypass the licensing that Sun had. So basically, Sun makes money, or now Oracle makes money by licensing the Java virtual machine, right? So for example, every BlackBerry device has to pay money to Oracle for that virtual machine that's running on a BlackBerry device. So that is one of the important things and reasons for Dalvik, but it's not the primary reason. The primary reason was actually technical. I happened to be neighbors with a guy who wrote Dalvik, so I kind of had privilege to talk about that. And basically, when they looked at mobile, they basically said, you have Java virtual machine, which is the one-size-fits-all virtual machine from a tiny little phone all the way to a supercomputer that's sitting in a data center, right? And those are fundamentally different machines, right? So they basically look at the constraints that a mobile platform has. And they basically said a phone is gonna be battery powered, and a battery is not gonna get revolutionary better anytime soon, right? So we're gonna have a slow evolution in batteries, but batteries are gonna be very low in power for a very long time. So they basically optimize the virtual machine for purposes of the battery powered devices, right? And they also optimized it for size. So Dalvik does some really interesting and unique things in terms of being well positioned for registry-based chips, such as ARM, which tend to be better on battery than Intel chips. It does an interesting job of saving memory by not loading all the classes into RAM, which you don't have a lot of on the mobile device, and so forth. So basically, the core, the engine of every Android app has been highly optimized for purposes of mobile computing. So that kind of gives you an idea where it fits well in terms of the enterprise sort of solutions now there. So that's a little bit about Dalvik. We can talk about that later on if there are more questions on that. But I'm going to move slowly to the framework space. So the framework space is basically the application framework. This is mostly the clean room implementation, brand new code that was developed, purpose-built for Android, right? So again, it looks like this, and within this chunk of stuff, we have the standard Java libraries, which like I said, everything but nine lines of code have been clean room implemented, so from scratch. It's based on Apache Harmony project, if anybody cares. But this is basically more or less standard Java. Android framework libraries and system services were built specifically for Android. And that's basically the power that we're exposing to the application developers. So as an app developer, all you care about is what's available in this layer. You don't really care about anything that's down below in green in native land. Just to kind of give you an idea, this is sort of the blueprint for how location system works, right? So everything from the moment my app says what's my current location down to the actual kernel driver for location. So I don't expect you to understand it at all, but I just kind of wanted to point out that there are a lot of moving parts. There are a lot of levels of abstraction. So just kind of like in a nutshell, what we have here is we have the client app and we have the service app, right? So these are two separate applications, and then down below, this is the kernel, right? So this would be my screen that says, I want to know what is my current position, right? But that screen now talks to this guy, talks to this guy now talks to the binder driver, which then sends the request up here, which then eventually makes it to this guy, which then eventually makes it to this guy, and then eventually goes to the driver. And all along, we're going from Java to C, from process 1 to process 2, back to Java. So there are a lot of these we're crossing these bridges between different languages and different processes. So to some people, this seems very inefficient. And anytime you introduce an abstraction, you're kind of losing in efficiency. But Android kind of chose this architecture mostly for security reasons, because now this service can actually run as a system user, and the client can run as an underprivileged user. So basically, they're now separated in terms of security. So you have kind of like a superior process and a less superior process. So that's kind of why there's a level of complexity introduced in Android, again, to make the security a little tighter. So just an example of how one of the frameworks work. Keep in mind also, when they were designing the framework, right from the get-go, they planned to have this run on many, many different devices. So what that really means is not just different hardware configurations, but also different form factors. Right? So Android apps are designed in such a way that they should look very good on a tiny little phone, as well as on a bigger tablet, as well as on a gigantic big screen TV. Right? So they should scale up properly. So that's one of the considerations that they've addressed, and they've done a reasonably good job, given that we have, I believe, 850 different or 900 different devices certified out there in the wild. So lots of different Android devices, and they all pretty much run the same apps, the same Angry Birds or whatever is your favorite app. Another example of a framework that I find interesting is the media framework. And the reason why I'm mentioning it is it sort of shows the philosophy behind the platform. So when they were designing the platform, they said, all right, well, we need to be able to play media, right? Videos, music, audio, whatever. And there are many, many different codecs and formats out there. So what they did is they took everything that was license friendly out there. They bundled it all together and put it into the platform, which makes sense. But what about the things that are not license friendly? What about those Windows media formats or Apple codecs or things of that nature, which you couldn't put into an open source project because it would pollute the license pool, right? So what they did is they basically they built this on top of a very pluggable framework. So the media is, you can think of it as basically a bunch of slots. It's something called OpenMaxIL. So basically, you can plug in different frameworks. What that means to an enterprise is that if the proprietary codec that you're missing is not included, that you need is not included, you can go and license it and then basically just put it into a slot. So it's a very elegant way to expand the platform, yet keep it license friendly for general purposes, right? So this is the case with media. This is also the case with VPN and a couple of other frameworks that are sort of important to the enterprise concerns. So finally, at the end of the day, we have applications. So like I said, at the end of the day, you need to provide some value to your users. That's why they're using the device in the first place. So in terms of applications, like I said, they boil down into two sets of applications: those that are already built into the platform, and those that the user downloads. So these are sort of etched in stone. You cannot get rid of them, and these user can download and remove whenever they chose to. So the question that always comes up is, well, what about fragmentation, right? So you have all these different devices. There's a lot of talk at the conference about bringing your own device to the organization. So if that's the case, then a CIO or CTO is going to have a case of a very non-homogeneous device base, and they're going to want to run the same apps on all those devices. How do you ensure they work? And right from the get-go, Android had something called the compatibility test suite to ensure a compatibility of a device. Now, basically, compatibility is, there are two things that make up the compatibility test suite. One is a battery of tests. So it's an automatic testing mechanism. You take your device and you run it against that set of test cases, and you either get, yes or no, true or false. It's binary. You either pass or you fail. That's pretty straightforward. The other set is a document. It's a pretty large document that basically has a lot of musts, shoulds, and optionals, right? So it says things like your device must have the following sensors, should have, such and such amount of memory. Optional, it can have telephony and so on. So you kind of look for things that are important in terms of being compatible. So that's basically where we're at with that. Compatibility was there from day one, but it's been more important recently. And what's important also to mention about compatibility is that the only sort of teeth in the whole thing is Google itself. So if you as an enterprise know that you're going to be modifying the Android, but you do not care about being on good terms with Google, you don't really care about compatibility. There are lots of great cases where that's exactly what happened. For example, Amazon Kindle Fire didn't care about compatibility, so they're not a compatible device. Cisco CS, the business tablet, same thing. DoD with NetWarrior, basically putting Android in the hands of all the in the battlefield. They don't care necessarily about compatibility. So the only thing you do is if you're targeting the consumers and you want to license Google apps, such as Gmail, Gtalk, Google Maps, the Android Market, or whatever they call it this week, Google Play, right? So that's the only time you really care about compatibility, to be precise. So it's mostly for consumer concerns. So in terms of the Hello World, what the tools look like, we wanted to kind of just show you, hey, what does it look like to develop for Android, just in 60 seconds or less. I have a little Hello World program that I can walk you through what creating. So basically, when developing for Android, all you need is Eclipse. Well, you actually don't need Eclipse. You just need the Android SDK. So it's a free software developing kit. You get it from android.com. Eclipse is optional, but it's very useful. So basically, what I'm doing here, as I'm saying in Eclipse, I'm going to create a new Android project.
Does Eclipse come from Google?
Eclipse is an open source project, comes from eclipse.org. And it was basically started by IBM way back when, and IBM open sourced it. And since it's become the de facto tool for a lot of Java development, so Android builds on top of that. You don't need it. You can use IntelliJ, you can use Notepad, whatever editor you prefer. It just happens that a lot of people in the Android development community tend to standardize on Eclipse. So there's a concept of a project, so I'll create a project called Hello App Forum. So that's what I'm doing here, just basically specifying project name. Then I pick the target that I'm targeting. So basically, this short list here are various types of Android operating system that are out there. Some are the official ones. So for example, if I look at here, Android 403, it would be the official Android open source project, or AOSP. Whereas the one right above it is the Google proprietary one from Google Inc. So it's got extensions like Google Maps and so on. And you may even find the ones from like HTC, Kyocera, Sony Ericsson, et cetera, et cetera. You as an enterprise can also create your own type of Android flavor, and then basically have developers develop for that particular flavor.
And that supports things only specific to your device or your line of devices, right?
So if you create your own flavor of Android, it's going to support standard Android plus the extensions that you have. So for example, Motorola may create a suite of applications that deal very well with two-way radio and barcode scanning. So that would be the extra stuff that they provide on top of Android. So if I, as a developer, wanted to develop barcode apps that specifically are targeting Motorola devices, I would download their extension set.
But the extension is an extension, or is a superset?
So it's a
the standard and everything
Yeah. So the question is, what is really the extension? It's meant to be the whole and complete operating system. So typically it would be a superset, not just the delta.
Okay.
Yeah. Typically it would be the superset. So I'm going to stick with a vanilla ice cream sandwich. And so on the next screen, it's basically just asking me, hey, what's your application name? This is just simple English name. It doesn't really matter. It's not significant. What is significant is the package name. This needs to be unique. And it's usually going to be reverse of your domain name. So it may be something like com.maracana.android.hello, for example. And app forum, just so I don't collide with something else. So that's basically all I need here. I'm saying yes to an activity, which is basically going to be a single screen. I'll talk more about this in the next session if anybody's around. And I'm specifying what is the minimum SDK. So I am targeting the latest, greatest Android, the ice cream sandwich. But what if I wanted this to run on all the versions? So I get to choose how far back I'm going to allow this app to run on, because I have to support it on the older devices. So I could, for example, say, well, let's run it on as old as Honeycomb, so which is Android 3.0, right? So that means that my universe of possible devices that this app is going to run on is Honeycomb to ice cream sandwich, right? So I click Finish, and I basically get the Hello App Forum application here. Now, I'll just kind of like give you like a super high level overview of this application. So basically, what an application consists of is a little bit of Java code. I'm going to show you like this. So basically, we have a little bit of a Java code here. Okay, so this is your business logic. This is the actual brains of your application. Then you have under resources, you have things that are not code yet your application needs. So these are, we call them resources. And that includes things like images, graphics, sound clips, things that are there, part of your app, but are not code, right? So lots of XML file, things of that nature. And then finally, there's a file called manifest file, which is sort of the big picture, what your application really comprises of. It's not a big file, but it's the main file explaining the components of your app. So that's kind of like an application in a nutshell.
So like bitmaps and icons would be under resources or under assets?
Well, they can go under both, but if they're structured, they go under resources. Under assets, you probably know that because a lot of web apps, that's where they put their stuff. So if you're writing an HTML5 application, typically it's going to be less structured, so stuff goes in here. But for a native application, we usually put everything on the resources. So I can basically click on Run on this, and this application will just basically come up on the emulator right here. Now, I'm running it on an emulator. I could just as easily run it on the real device. And I kind of want to point out the difference between an emulator and a simulator that other platforms tend to use. So Android is sort of unique because it uses the actual emulator. And speaking of emulator, perfect. There's a little bug in Eclipse that that basically makes it forget about the emulator that I already have in place. So it's starting a new one, which is going to take a while to start. So what I'm going to exactly. Well, the tools, it's good that this happens. The tools are flimsy a little bit, right? It's, there are little quirks here and there. They're very feature-rich, but they're quirky a little bit. The way I see it, the price is right, so I can't really complain too much about that. So it's going to start up now. There isn't really a 1-800 number you can call and complain about Eclipse bugs or anything like that. So, but the tools are free. So that's the Hello World app that we just wrote. So it's up there running. Of course, I could now go and modify it, and this would be my user interface here. It's sort of like a Dreamweaver. You drag and drop stuff, and you make it into whatever you want it to make it. It takes a little while to load up, but it's going to come up. And I'll talk about this more in the next session. So that's the Hello World. So that was the SDK, where to get it from. By the way, all these slides are available on the website, on maracana.com. I'll tell you about that later. this was creating a new project, anatomy of that project that we just drew, and this was running it on the device. So that's basically that, and this is still loading up, I guess. So it's.
Your experience, Windows versus iOS to do your development is.
I have no experience with iOS or Windows Mobile.
Not development, sorry. Developing your Android on an Apple versus on PC.
Okay, in terms of the development environment, good point. So the question is about the development environment for applications. So basically, Windows, Mac, and Linux are supported, and they're about equally good or bad. So they both have their own quirks, but it's not like one is significantly better than the other. When it comes to platform development, Windows is not supported, so you got to go with a Mac or a Linux. So that's basically how it boils down to. So, but for the most part, it's very similar. Okay, so I want to talk a little bit about security because security tends to be one of the primary main concerns for enterprise purposes. So first thing to point out in terms of security is the application sandboxing model that Android has. So in an Android environment, basically an application is its own process, right? So each application is going to run as its own Linux process, right? And what an application really is, so I draw it like this as a little silo. What an application is essentially a collection of various application parts. We call them components. I sometimes refer to them as main building blocks, and I'll talk about them extensively at the next session. But they're basically activities, i.e. screens, services, things that run in the background, receivers, and providers for data. And then we have the Dalvik virtual machine, right? You may also have additional resources like permissions, maybe native libraries, maybe databases, files, other resources, and things like that. But what's important is that we have a single Linux process for an app, that we have a dedicated Dalvik virtual machine for that application, and then everything else runs on this application. So basically, the reason why this is significant is that it provides for isolation between apps. So each app is an island on its own. One app cannot touch another app, right? So they're basically vertical silos. So that's a good thing because it provides for security in such a way that whatever you want to do within this box is okay, and you have all the power within this box, but the box itself is limited, right? So I'll give you an example. So if I'm writing, let's say Angry Birds, just because it's very process intensive. So let's say I'm writing a game, and I want this game to work extremely well, to be really fast and so forth. Well, I may choose to do parts of that app in C++, like for example, all the computations of the trajectory of the birds and such, the physics engine, right? That's pretty involved mathematically. So I may choose to implement that as a C++ code, right? In Android, that's perfectly fine, and that works great, and that's exactly how Angry Birds works in many, many other enterprise applications as well. So basically, it allows for Java to talk to C because everything is secure as long as it's within this container. So the fact that we have some C library within our application is fine. Now, that's because the kernel, the Linux kernel, is the sole enforcer of the security. Now, if you compare that to BlackBerry, where Java is the enforcer of security, you cannot have Java then escape out to the C world, because then all hell goes loose, right? So, so basically, in BlackBerry, you're much more constrained with respect to what you're allowed to do. So in Android, you can have richer applications because the security is implemented much deeper down in the kernel level, right? So I use the Angry Birds as an example, but it could be an enterprise application as well. So for example, the barcode scanner, well, there could be a native driver, C++ driver. In Android world, that's fine because my app is going to be able to talk to that driver as long as that driver allows us permissions to talk to it. So we can basically do that quite easily. So that's a feature.
The main drawback that these apps tend to take a little bit longer to start up on the device.
So the question is about.
App might take a second and a half before it comes out.
The question is about the startup of the applications. There's a that's arguable if it takes longer to start up on Android versus, for example, iOS. The applications. I'll talk maybe a little bit about Zygote later on. Things start really quickly, and in absolute terms, they start about the same time on Android and iOS. What iOS does, it's a little trick. I don't know if you guys know about that, but when you launch an application, it appears like it already started. And actually, what you're seeing is just the picture of that application. So it throws up a JPEG or PNG file, and it's cranking in the background, actually launching everything. But all along, you think it's already started because by the time you touch the screen, it's actually replaced with the real thing. Android doesn't do that. There is an option for that. They were kind of thinking, should they do that trickery or not? And they provide it as an option, but it's not on by default.
But you can do that within the Android app itself, though. You can throw up.
Yes. Yeah, you can. Yeah. So that's a little bit about sandboxing. Now, this is a much more complex picture, but let me kind of walk you through this a little bit. So it kind of explains what happens with all the processes once they're started. So you can kind of think of it as the time goes this way, right? So this would be time 0. We turned on a device. Kernel got booted, right? So what we have here is we have a bunch of native daemons. Some are Linux related, some are Android related. So that's the native C, C++ code. Then we have Service Manager. This is, again, native code. Then we start a Zygote. Zygote is basically the pre-warmed up version of any future app. Every app in the future is basically just a fork off of Zygote. That's kind of how that works. And ultimately, we have now the first Android app, which is the system service. And then we have many, many different apps, right? 10, 20 different apps that you have running in your pocket right now. The point is that these apps are sandboxed. So each vertical box is basically a sandbox on its own. Each has its own HAL, its own system, its own JNI, its own Dalvik, its own application code finally. So each one is pretty much separate on its own, and that's why it's very powerful within the box, but the box itself is limited. Okay, so that's kind of how things work. Now, because you have so many copies of Dalvik, remember back to Dalvik, why did they write it in the first place? Well, you have so many copies. For each app, you have a Dalvik. So you guys probably have about 10, 20 copies of Dalvik in your pocket right now, right? So they had to optimize Dalvik for memory extensively. So Java would not have worked very well. So they did some interesting things to optimize for loading of those 2,300 libraries that each instance would need. So if you multiply that by 10, 20, you kind of get a lot of waste. So they did some interesting things to optimize for loading of the libraries and things like that. And another reason why we have Dalvik as opposed to Java. So that's kind of just to kind of give you a high-level overview of what that looks like when it's all said and done. But ultimately, each application basically cannot do anything that can adversely impact other apps user or the system, right? So what we mean by that is if there are things that potentially cost money or intrude on privacy or whatnot, an app is by default not allowed to do that, right? So for example, read my contacts or send SMS messages or keep the screen on because that's going to ruin the battery, waste the battery, and so on. So that's basically, those are some limitations that we have. Like we said, kernel is the one that enforces the security at the end of the day, which is important. Now, what happens if you do want an app to be able to connect to internet, send SMS, read your contacts, keep the screen on, and so on? So some apps have a legitimate need for things like that. So what happens in that case is an app simply says it needs permissions. So you as a developer, so this is the client app, this is what you are writing as a developer, and this is some service that runs on a platform. So let's imagine I am trying to, this is a location service, and I want to know my current location based on GPS. Well, that's a potentially dangerous thing, right? Because GPS uses a lot of juice, a lot of battery. So GPS service or location service is going to require a permission for use of GPS, right? So you as a developer, you need to specify that your app uses a permission. So you say this app uses a permission for GPS. At install time, user is basically confronted with a screen like this that basically says the app is using the following permissions, blah, blah, blah. Do you grant it or not? Okay. So once you grant it, at install time, this app is now made a part of the Linux group that allows it to do that. So again, it's kernel managing the security. So this works great. The only downside to this system is the so-called social engineering vector of attacks, right? Because this is usually a very small screen. Apps usually ask for a lot of permissions, and we as users just tend to want to play with that app right away. We want instant gratification. So when was the last time you read one of those, licenses or permissions or any of those, right? We tend to just say yes, approve. So that tends to be the sort of the weak point of this security model. It's only
Unless it's Facebook. No.
exactly.
There is no way to tell, I want you to use the GPS but not the network.
There is no, yeah.
Approve all or deny all.
Exactly. So you either grant all permissions or none, in which case the app doesn't get installed. And this is all done only once at install time. So unlike BlackBerry, which allows you to fine-tune it and change it subsequently, Android doesn't. Yeah.
Is the rank ordering of those services under developer control, or is that a default inside Android?
The order of
A
this,
lot of wimpy ones that are like, yeah, it's okay, put down delete your hard disk and contact your mother way down below the list.
the order is implicit, so system organizes it. Yeah.
When you create an app on there, does it create a corresponding service? Like when you create a Hello World app, did it create both an app and a service?
No, it doesn't. The service is already there. So Android comes with about 55, 60 services as part of the ice cream sandwich. That's the latest count. So the services are part of the so-called system server umbrella. There's an umbrella under which there are many, many different services like Bluetooth, Wi-Fi, telephony, location, NFC, etc. Yeah. File system, Android has a file system. It's also a sort of unique type of a file system. Basically, there are three partitions or mount points that are of interest. System is where this is where your operating system is basically located. And what's interesting about this partition is that it's read-only. So user or the app developer have no access to this partition. You cannot modify anything. So that's a good thing from security standpoint. The user data is on the data partition. And more specifically, each app stores data in a data folder where each app has its own sandbox in the file system, managed again by user Linux UIDs. So you have an app has a sort of a private place in a file disk system where you can store stuff. There's also the SD card, which is sort of the Wild West of storage. It's free for all storage.
There is a place to have an explanation of what every folder in the Android structure means for system and data, for instance. A way to have, because system app probably let me know something about it, but how can I know that the data of an application goes into data or data whatever, the structure of the Android file system? There is a place to consult that document, the book, your book, or whatever?
So is it documented anywhere? Nothing is officially documented. I did write about that. I have a chapter or part of a chapter dedicated to how the file system is organized, yes. But a lot of things that go underneath the hood are just black magic. So there's no official documentation. The official documentation is the source code itself, all 3.5 gigabytes worth of it. So it's all there if you look for it, but it's a very painful to find what you're looking for. So we do a lot of that kind of work. So it's all just reading the code, basically. So I want to go through a couple of enterprise features that are interesting for Android. So according to Google, more specifically, Google has an enterprise team within Google. They've been baking things into the Android from security, from enterprise point of view for quite some time. So in Eclair, they added a secure Wi-Fi. They claim to have added a VPN. In Froyo, they added a couple of things, more notably remote services such as remote wipe, remote lock, and so on. Gingerbread, nothing really significant. And Honeycomb and On, they added the full disk encryption. So those are things that are sort of relevant to the enterprise. Now, one thing that I want to point out is that Google itself does recognize enterprise as significant, but it's not focused at all. Google is 100% focused on the consumer. So we know, you guys have been hearing about the consumerization of IT quite a bit at this conference. So Google basically is focused on the consumer because the numbers are substantially larger. For the enterprise, what they do is they essentially provide the plumbing. They see themselves as the ones that are responsible for providing the infrastructure for the enterprise features so that everyone is on the same page, but they're not going to build a complete solution. Okay, so that's very interesting from the enterprise standpoint. So Android operating system has very good core, very good plumbing for a lot of enterprise things, but it's by no means complete. Right? So you as a final end user, enterprise end user, you still have a lot of missing pieces. Luckily, there are third-party companies that are emerging that are filling in the void, and that's exactly what Google is expecting. So they're expecting third parties to basically come in and build different apps that complete different parts of the picture and make it all happen. With respect to bring your own device to the office, Google basically acknowledges this as an issue, right? Right now in corporate America, most of us have the company-issued BlackBerry and personal iPhone or Android device. And that's probably not what the future is going to look like. According to Google, the future is going to be a single device. And it's likely going to be your personal device. So the same device that you use to download Angry Birds and other viruses and spyware, you're going to bring to your office, and you're going to get on a corporate network, and you're going to access your secure corporate network with, right? And of course, a lot of CIOs are like freaking out. No, there's no way this is ever going to work out, and so on and so on. About half the corporate America thinks this can work out and it's great, and the other half is like, no way. So it's very religious at this point. Android does provide for something that could make people happy. So it's called the Device Policy Administration, and it's an API that allows you to create applications that can administer the device, right? So you can create these apps that are uber powerful. They're so powerful that they can wipe out your entire device in case it's lost or stolen, right? Or basically factory reset it, or remotely back it up if you just lost it, or can enforce how strong your password is, or how frequently, how soon the screen gets locked, etc. So there is an API for that. Again, it's just an API, it's just the plumbing. You still need to build apps on top of it, but third parties have been working on that for a while.
Yeah, so when I added corporate email to this device, it forced me to add a device PIN.
Exactly. That's exactly the type of a thing. So your CIO may say, fine, if you're going to bring your own device to work and you want to use it on a corporate network, that's okay, but you must allow me to administer your device. And that's sort of that middle ground where it could make the IT managers happy, and you are giving away a little bit of rights to them, but in exchange you can use you only have one device in your pocket as opposed to two. VPN. VPN I mentioned earlier when I talked about Media Framework. I said how Media Framework is built to be pluggable, right? And similar thing was with VPN. If you remember that chart that says, baking in the various features in Android, I mentioned that they added VPN way back when in Eclair days. But it was a VPN that nobody in America uses. It was basically not very useful at all. So I think about 40% of corporate America uses Cisco VPN, right? And that one wasn't supported because of the license issue. So again, it was one of those pluggable cases. As of Ice Cream Sandwich, they actually allow for an easier way to plug in VPN. So this really helps with that aspect, and this was a big point for a lot of enterprise customers. One thing that I wanted to mention also is the cloud to device push. So basically, sometimes you have enterprise applications that you need to send push messages to a particular device to send notifications. and such. So there is a architecture for that. It looks like this, and I don't want to get into the technical details of that, but in a nutshell, this is your application, your enterprise app, whatever. It could be like an email app, or for example. This is a particular user's device. So if there's something that your app server knows and wants to notify the user, it would basically send a message to the cloud, and the cloud would then notify the user, right? So that works great, except you got to keep in mind that this is a Google Cloud, right? So you are basically running your proprietary sensitive data through a Google Cloud. Some people may be uneasy about that. So one way to kind of get around that is to basically use the cloud or this architecture just to tickle your application, to basically tell it, hey, I'm not telling you what's new, but there is something new. Why don't you go over secure connection and retrieve the data? So that's kind of a way around that. Although I'm seeing companies also build equivalent architectures to support something very similar that doesn't run through a proprietary cloud. Markets, you guys, if you have apps at the end of the day, you got to distribute them. You guys know about Google Play or Android Market. Amazon is another big one. But what's interesting is we're seeing a whole bunch of boutiques emerging that are sometimes enterprise focused, right? So Cisco, DoD, companies like that, they're launching markets that are private or semi-private, that are highly curated, very tough to put apps in, and so forth. So we're seeing an emergence of that, and that's definitely a good thing. Also, as an app, as an enterprise, you can also do something called side loading. In other words, directly distribute apps, and it's quite easy. It could be as simple as putting together an internet page and putting all the apps on top of that page. So basically, the conclusion behind all this, what it all boils down to, is Android's been growing quite a bit. These are the numbers from a couple of weeks ago. So 500,000 new devices activated each day. I think the number is going up to like 850K now. 2.4 billion apps downloaded, et cetera, et cetera. So huge growth. You guys know all about that. 800 plus devices on the market out there in the wild. But basically, when it comes to long-term advantages, I tend to, like I said, prefer things that are fundamentally different as opposed to has this feature, doesn't have this feature. And basically, the key point is that Android is open, and that's something that differentiates it from anyone else. So look for opportunities where you need to customize the operating system. So for example, you may have unique devices, right? Maybe it's putting a mobile platform in cars, airplanes, space shuttles, or satellites, things of that nature. Tractors, for that matter, have done that. It could be for unique uses. I mentioned DoD, public safety is another example, enterprise customers, etc. Or it could be for specific verticals. So those are kind of the areas where Android is going to outshine any other platform for a very, very long time because it's a fundamental difference. And a lot of people ask, well, what's going to be next big thing in Android? And the answer is really we don't know. Nobody other than Google knows. But what I do know is that it's going to be the breeding ground for all the future innovations, just because the fact it's open and there's so many different parties involved with it.
How stable is the operating system itself?
How stable is it? It's stable enough that DoD is using it for mission-critical safety. It's stable enough that NASA sent the most powerful ever satellite to space. The first 32-bit computer was Nexus 1 that was ever sent to space, right? So it's stable enough for life or death situations. Cool. Thank you.